Okay, ladies and gentlemen of geometry, here is 12.3. We're changing gears here now. Instead of prisms and cylinders, now we're looking at pyramids and cones. And it's kind of the same idea, except you got to think a little bit about what shapes you're dealing with. Okay, so this would be considered a regular pyramid. That means, all four sides make a shape. So you've got vertex, your lateral edge, your altitude. Notice your altitude is kind of the height inside, and your slant height is going to be the height going up the side. It's a little bit different than kind of what you're used to. So if I kind of look at this from the side angle, so if this was a prism, this would be your slant height. That's going to be considered your altitude. Okay, so this altitude is on the inside of the shape. The slant height is on the outside. So this would be a regular square pyramid. This one on the right here would be considered a pentagonal pyramid because the base is a pentagon. Okay, it's a five-sided figure. So if I consider this, what does my net equal? So what does my net look like? My net will look like this: a square with four triangles coming off the sides. All right, so my slant height, which is L, it's often denoted as L, is going to be this length right here. Well, what I need to realize is that that is the same for all four triangles. Okay, so that's going to be the same. So lateral area, if you'll remember, means no base area. Okay, so I take the area of the lateral sides, but no base. Okay, so I get no bases included in here. So if I look, I'm basically taking this side times my slant height divided by 2 times 4. Okay, so let me say that again. I've got this length, this edge here, times my slant height divided by 2. All right, but then I multiply it by 4. So if I just go, I'll call it a base edge, base times slant divided by 2, but then I'm going to multiply it by 4. Well, if I rework this a little bit, I can just call this 4 base times L divided by 2. Why'd I go 4 bases? Well, 4 bases is going to be the perimeter of the base. Okay, so the perimeter of the base is what I want. So I'm going to take the perimeter of the base times the slant height divided by 2. That is what you should be putting into that note sheet. All right, you should put that in your note sheet for the lateral area of a regular prism. That is to take the perimeter times the slant height divided by 2. So if I take a look here, this is 4. That means all 4 sides are 4. So I'm going to take the perimeter of my base times my slant height divided by 2. So 16 times 6 divided by 2. So that's going to give me 48 square inches. Okay, that's all I'm doing. Perimeter of the base times the slant height divided by 2. Now, if I have a hexagonal pyramid, remember, a hexagon has 6 sides, the base edge of 9, and a slant height of 7. All right, so my perimeter is going to be 9 times 6, which is 54. Now I want to take 54 times 7 divided by 2. So again, perimeter is 9 times 6. Slant height is going to be 7. So I'm going to multiply those together, divide by 2, and I get 189 centimeters squared. So now, how does that change? What do I have to do? For a surface area, remember surface area is just lateral area plus the area of the base. So now that's exactly what I'm going to do. I'm going to do perimeter of the base times the slant height divided by 2 plus the area of the base. And this is what it would be shorthand, okay? So perimeter of the base, L is my slant height, big B, uppercase B, is going to be area of the base. You only have one of them, okay? So I'm going to take, this is what I would write down in my note sheet right there. And I would even write these pieces too: perimeter, slant height, and area of the base. So if I look, what's the surface area of the square pyramid to the nearest tenth? If I look, 16, that's the altitude. But that's not what I want. I want my slant height here, okay? I need the slant height. Well, if I look, that is 16, that is 6, that is a right triangle. How can I figure that out? For those of you that said Pythagorean theorem, congratulations, you're correct. So 16 squared plus 6 squared equals c squared. A little calculator mashing, and you get this to be 17.09. So that's going to be my altitude. All right, that's what I want to use. So I'm going to take perimeter of the base times the slant height divided by 2 plus the area of my base. So perimeter of the base is going to be 48 times 17.09 divided by 2 plus area of the base. Okay, the base is a square with side of 12. So that's going to be 144. So now I'm going to multiply 48 times 17.09 and divide it by 2. I'm going to get 410.11 plus 144 is going to be 554.1. Nearest tenth means 1 decimal point. So it's going to be centimeters squared. All right, so perimeter of the base times the slant height, but we had to figure out what that was, and then we add the area of the base. So now, how does that change with the cone? The answer is not very much. Okay, we still want the slant height, but if I think about what do we call the perimeter of a circle? You know, what's that distance around the edge of a circle, around the outer edge of a circle? Well, we call that the circumference, right? So my circumference is either 2 pi r or, diameter times pi. So what that ends up looking like is this. 2 pi r is going to be my circumference times my slant height divided by 2. Okay, I just designate that, hey, instead of perimeter, my perimeter, I know what the perimeter of a circle is. It's called a circumference. All right, and I know that it's double r times pi. So this is going to be how I figure out the lateral area of a cone. How does that change for surface area? Well, I keep the lateral area, but then I add the area of a circle. Which is just going to be pi r squared. How do I know it's pi r squared? Well, I know my base is a circle. I know that, it's not going to be a hexagon or pentagon or octagon or anything like that. I know it's going to be a circle. I just got to know what the radius is. So let's look here. Waffle cone is 5.5 inches tall. The diameter of the base is 2.5 inches. Find the lateral area of the cone. Well, if I look at this waffle cone, that's 5.5. Diameter is 2.5. I've got some work to do. First off, 5.5 inches tall, that's my altitude. That is not my slant height, which is what I want. So again, I'm going to use Pythagorean theorem. That's going to be 1.25. So I'm going to set it up like that and figure out what c squared is. So this is going to be 5.64. So they want lateral area. So they want 2 pi r times L divided by 2. Well, I already know what 2r is, so it's going to be 2.5 pi times my slant height divided by 2. That's going to be my answer. All right, so a little bit of calculating, and away I go. 2.5 times 5.64 is going to give you 44.296. That's my answer. So last little piece here, lateral area and surface area. So lateral area is going to be 2 pi r divided by, or times slant height divided by 2. Okay, or I could just go pi RL, simplify it. All right, then for surface area, I'm just going to take pi times the radius times slant height plus the area of the base. So I'm going to take pi times 7.4 times 15. 7.4 times 15 times pi is going to be 348.72. Okay, and all I did to cancel out the 2's, I have a 2 on top, 2 on bottom, they can cancel out. This might be the short version of what I write in my formula sheet. So then from there, I just add the area of the base, so that's going to be pi r squared. So that's going to be 7.4 squared times pi. And that's going to be 172.03. So I add that to the 348.72. And that's going to be 520.75 centimeters squared. So there's my lateral area. I add that. There's my surface area. Okay, last piece here. Lateral area. Remember, pi times radius times slant height. Surface area, I'm going to add pi r squared to this. So pi times 0.8 times 2.2. So that's 5.529. Then that's my lateral area, so that's millimeters squared. So then I'm going to add 0.8 squared times pi. 2.011. That's going to be 7.54. So there's my surface area. There's my lateral area. Okay, that's what I'm trying to get you guys to do for 12.3. Just start thinking about, if I start pulling this apart, what's it look like, and kind of how can I figure out those pieces. All right. All right, work on the assignment and let me know if you have questions and what we can work on.